Hi, I'm Eugene, and if you're anything like me, you could have heard about JWT, but you lack that fundamental understanding. Once you're done watching that video, you'll have a clear understanding of what JWT is, how does it compare to other authentication and authorization methods, how does it actually work under the hood, and finally we will finish this video with a short demo where I'll try to create the JWT token manually in Python. Let's begin. JWT stands for JSON Web Token. It's a special kind of token that can be used for authentication and authorization purposes. And it's crucial to distinguish these two concepts. Authentication is the process of verification that you are who you say you are. Basically, when user provides login and password on some website, the server, will verify that this user with this login or email exists and that the passwords match. This part is authentication process. Authorization, on the other hand, is the process of verifying the permissions of that user or entity, whether this user can access this part of the system. For instance, if our website has an admin panel, we want to be sure that only users that have a role of admin can actually access this part of the system. And this process of checking whether this user has a role of admin is called authorization. Now let's look at each part in detail. First, the header. The goal of the header is to contain the information about the algorithm that is used for encryption of the signature and also the type of the token. In our case, that's JWT token. Then the header gets base64 URL encoded and we arrive at the following string that becomes a part of the token. The first part of the JWT token is header. Next we have a payload. The payload consists of claims. There are three types of claims in the payload: registered claims, public claims, and private claims. Registered claims are the claims that are agreed upon certain convention to have certain meaning, but they are not mandatory because in the end you are the one who implements this authentication algorithm. Here you can see a short list of these main registered claims. For example, is, which would be issuer, which means a principal that issued the JWT token. Then sub stands for subject and identifies the principal that is the subject of this JWT token. Then the audience, which would mean the recipient of this JWT token. And the last one we are gonna cover here, the EXP, expiration time, which would mean the time when the issued token would be counted as expired. Let's look at our example here. We have a subject which has some ID. We have a name that would be a private attribute specific to our application. Looks like a name of the user. Then we have whether this user is an admin or not. In that case, he's an admin. And we have IAT issued at the Unix timestamp when the token was issued. So the server could as well use issued at to calculate the expiration of the token. In the same way as with the header, the payload would get base64 encoded and we would get the following string from it. And finally, the signature. Signature is used in verification process to make sure that the token wasn't changed along the way. Here is how it's constructed. First we take base64 encoded header, the following string, then we add a dot to it and add the base64 encoded payload. So essentially this is the same part as we see right here. And then we use specified hashing algorithm from the header to encrypt this string using the secret that we provide. So essentially, our server would take that base64 encoded string, take the secret that is stored only on the server, and provide us with this hash encrypted by the secret. all of that together is our JWT token. Now let's have a look and discuss a practical example of how the authentication with JWT could look like in real life. We have a browser here and our server. Let's say we have a user who wants to log in to our website and leave some comment under the video, which you are very welcome to do on YouTube. First step is to provide the login and username and try to authenticate through our login form on the website. As a second step, our server would validate the user based on his provided username and the hash of the password by comparing it against the hash of the password that we store in our operational database somewhere here. And if we have a match, meaning the username and password are correct, then the server would issue the JWT token, and it would send the JWT token back to the browser. And the browser could store it either in cookies or in the authorization header. As a next step, number 4, when we actually make a request to leave a comment, the browser would include the JWT in authorization header or in cookies. And then in step number 5, the server would try to verify the JWT. And once it's verified, to authorize whether this user is allowed to leave a comment. But let's look even closer at this verification process. So step number 1 would be to decode the base64 encoded header and take the algorithm. If I go up here, so we would decode this string and extract an algorithm from here and verify that the type of token is JSON Web Token. Then step number 2 would be to try to construct the signature using server secret based on the header and payload that we get from the user's JWT token. So let's say our user got from the user certain token. In first step, we decoded this part, and now we know that this algorithm is used allegedly to create the signature. So our server would take this part and essentially take what user provides us here, put it in the hashing function, and apply our secret stored on the server to arrive at the signature. Then in step number 3, the server would compare the created signature from step number 2 to the signature that exists as a part of the JWT token that user provided us. And if they match, that means that user didn't tamper with our JWT token that the server provided him before, and it's valid. Because if user attempted to change something in the payload or in the header, then these signatures would not match, and he wouldn't be able to recreate the signature in the same way because the user doesn't know the secret that we have stored on the server. Then once the verification is done, our server would check the roles, for example, from the payload. If they have a role that allows the user to leave comments or set of permissions or whatever, then the server would authorize this action or not authorize it. And obviously, if the signatures didn't match, the server wouldn't allow the user to perform that action. In a nutshell, this is the JWT authentication process. Super quickly, let's compare JWT authentication to another very common authentication method called session-based authentication. The example is the same. So our user makes a login request with username and password. We make a database call the same as we did here to verify that username and passwords are correct. And then if they are correct, there would be another database call to create in the database sessions table a session for that user. It could have a bunch of columns there, but at least it would need to have a session ID, probably a date when this session is active from, and the date until which the session would be active 2. I have replaced, just for the sake of the simplicity, these dates with isActive attribute. It would create this session record in the database and finally send the session ID to the browser, and the browser would store it, for example, in cookies. So the next time the user makes a request, for example, to leave a comment, session ID is present in the request cookies. The server would extract the session ID from the cookies and make a request to the database to look up that session ID. First, if it actually exists, and second, if it's still active, because if we have an expiration date and it's out of the expiration date, obviously we do not want to allow that request. And then, if the session ID is present in the database, it would return the successful result to the user, and the comment would be created, of course, if the user has rights to do so. Actually, a small but crucial point about authorization here is that usually you do not store the role information or permission related information in the sessions table. And that would mean that even if the session exists, we would have to make another request to the database, for example, for roles table, to check if the following user has the role that allows him to leave comments. So already we have two database requests here. And these database requests would need to happen each time the user tries to perform an action that requires him to be authenticated and authorized. On the other hand, with JWT authentication, we do not actually do a lot of database requests. We make it once to validate the username and password, and as long as JWT is valid, the authentication and authorization process happens just on the server without touching the database. And that by itself is a huge advantage of JWT authentication method, because every request to the database is an extra load on the database and increased latency for the user, because it takes some time to perform these actions here. This video is already longer than I initially anticipated. I'm sorry for that. Yeah, that's my special quirky thing. I try to speak about something and then go in too much detail. Bear with me, we are almost done here. The one thing left is to show you the demo where I'll manually create the JWT token and then compare it to the results from PyJWT library, just to verify that everything that we have spoken about in this video, about all the steps, how to construct the JWT token, this is actually how it works. So we will compare the resulting tokens. If they match, it means our understanding is correct and we are good to go and create as many JWT tokens as we want. Alright, that's our manual JWT Python program. First we define a header, as you saw before. It has algorithm, it has type. Then we have the following payload, user ID, some username and the role. The first thing, we serialize the header and the payload as JSON strings. Then we base64 encode them and strip equal signs from the end. Then we will see the results of these encoded values. Then we create a signature, so we have secret key, we have message that consists from encoded header and encoded payload separated by a dot. And then we have our encryption call with HMAC library. We give it an encoded secret key, we give it our message, that's header and payload, and we provide it with the hashing algorithm. And then we digest it to get a hashed value. Then the signature gets base64 encoded and we strip equal signs from the end. Finally, that would be our JWT encoded header, dot encoded payload, dot encoded signature. Let's run it. So Python manual JWT, and that's our JWT. I'll put it right here. Next we have PyJWT library here, which kind of simplifies all that process. So just 15 lines of code versus 41 line of code, essentially doing the same thing, and the goal is to arrive at the same JWT token. We have our secret key, hashing algorithm, payload, user ID, username, role, and then we just call PyJWT. It automatically handles the encoding, the signing with our secret key, and formatting. So we provide it with the payload, the secret key, and the algorithm that it needs to use. And finally, we print the token. So Python PyJWT. Here is the result, and let's try search, and it matches. So that proves that our understanding of JWT token is completely correct. There is a website that I want to show you called jwt.io, and here you can validate your JWT tokens or play around with it. I'll paste here the token that we generated, and let's see what we have. So it shows us the decoded header that essentially has algorithm that we used and token type, JWT, then the decoded payload, so user ID, our username, the role admin, and the signature, which didn't match because this is the secret key that they have here on the website. That's not our secret yet. That just shows again that the header and the payload, they are just base64 encoded. They are not encrypted. It means that anyone can decode these values, which means that you should never store any sensitive information in the payload, just something that you would be okay for anyone to see. So the website shows us an invalid signature, and let's give it our real secret. Where is it? My super secret key, and it works now. So now our token is valid. And let's try one roleplay scenario. Let's imagine I'm a super malicious user who wants to trick the server into thinking that I'm a super admin, so I've updated the role, and then I would base64 decode it. So let's run it, and I think we need encoded payload here. So our token that in that case I would send to the server would look something like that. Header didn't change, then payload is changed because I have included the role super admin instead of just admin, and I would try to take that signature because I cannot recreate the signature without the secret key. So our server would receive that request and generate the token like this. Header, then payload. It's the same because it's just base64 encoded, but the signature wouldn't match because the attacker doesn't know our server secret. So essentially for that type of payload and header, the correct signature would be the following. But the attacker has no chance of knowing that unless he knows our secret, which he shouldn't know. That's how it works. You reached the end of the video. I hope now you have a crystal clear understanding of how JWT authentication works. If you enjoyed it or found it useful, then please leave a like, leave a comment and subscribe to the channel. I would be thrilled to have you here. YouTube thinks that you might like that video. Give it a try and let me know what you think. With that, thanks for watching and happy coding.